Okay, try to be quick. We're going to look on finding exact values, kind of using SOHCAHTOA. Here I'm given sine of A is 4 over 5, and A is given, it's less than pi and greater than pi halves. So that means what? Starting here, we're greater than pi halves but less than pi, so quadrant 2. So remember, that's opposite over hypotenuse, so that's 4 over 5. We're going to need to find cosine, so we're going to solve for what the adjacent is. We have opposite, hypotenuse, we need adjacent for this theta. Okay? Alright, so notice I've got 4 squared plus b squared equals 5 squared, Pythagorean theorem. Alright? B squared is going to be what? 5 squared minus 4 squared, which is 25 minus 16. 9, square root of 9 is 3. B is 3, okay? So, sine of A is 4 over 5. Cosine of A is 3 over 5. So I found cosine A and sine A. We'll need that for the problems, okay? Alright? Let's go down to B. We're given sine of B is negative 2 over root 5. So, if we rationalize the denominator, it's negative 2 root 5 over 5. And they give us B is less than 3 halves pi, less than 270, but greater than pi 180. That puts us, we're less than, as we start here, we are less than, turn that down a little bit, we're less than 270, 3 halves pi, but greater than pi. So here we are in quadrant 3. Okay? Remember we were negative 2, that's down. Notice I just put a 2, that's a distance. The negative is to kind of put where the direction is. We're going to square everything in the Pythagorean theorem, so negative goes away. So I've got hypotenuse of root 5. My opposite for my theta here is 2. So basically, a squared plus b squared is c squared. 2 squared plus b squared is root 5. 4 plus b squared is root 5 squared. So, I'm sorry, that's 2 squared plus b squared is root 5 squared. 4 plus b squared is 5, and I subtract 4 from both sides. B squared is 5 minus 4, b squared is 1, and square root both sides, b is 1. So now I've got sine is negative 2 root 5 over 5, and cosine is 1 over root 5. That's going to be what? Here's our 2, 1 root 5. Here's our theta. I rationalize that denominator and I come up with root 5 over 5, okay? Alright, we're not going to need tangent here, okay? Alright, so some of the questions they asked us were, find cosine of A. Well, we found that already, right? We found cosine of A was 3 over 5. They wanted cosine of B, and we found that, okay? Root 5 over 5. Alright, so then part C was, okay, cosine of A plus B. Well, we've got all the components, so it's pretty easy now. Cosine A, cosine B minus sine A, sine B is this. So we just plug in our formulas. 3/5 times cosine B is root 5 over 5 minus sine A, 4/5 times sine B, negative 2 root 5 over 5. And we just multiply it. Common denominator is 25. Okay? And here I've got 3 root 5 over 25 minus a negative 8 root 5 over 25, and that minus a negative ends up being a plus, okay? If we want sine A of B, this is part 4 of the problem. We just got all the components again. We figured out cosine and sine for both angles using the Pythagorean theorem, all right? So sine A cosine B plus cosine A sine B is root 4 over 5, root 5 over 5, plus 3 over 5 times negative 2 root 5 over 5, and we just multiply. That's going to be 4 root 5 over 25 minus 6 root 5 over 25, okay? All right? Here's one more problem. Same type scenario in a way. Here I've got, here we go, sine of inverse, so remember, inverse cosine, inverse trig functions are angles. So this is basically angle A and angle B, okay? So all I need to do here is, for this problem here, I know cosine's 1/2 and let's see, cosine's 1/2. I know what my angle is, right? It's 60 degrees, okay? All right. And what was I saying here? Oh, well, I forgot something. Okay. Anyway, so cosine's 1/2. I know inverse cosine 1/2, I'm going to have 60 degrees, okay? And sine would be, and they also limit this to, they said for this cosine problem here, that's what I wanted to tell you guys, okay? Angle A is, this is going to be my A, and this is going to be B, right? Sine of A plus B, and each one of these inverses represents an angle, okay? So for this cosine A, they tell us that they want A to be between less than pi but greater than 0. So in this quadrant here, okay? All right? And so when I get sine, it's going to pretty much tell me what I need. That helps me out. And also when I do B, later on, B, they want my angle B, this part here, they want B to be less than pi halves but greater than negative pi halves. So these two quadrants here, 1 and 4, okay? All right? So basically, this is sine of A plus B, right? So let's put that formula out. Sine of A cosine B plus cosine A sine B, all right? Well, let's find, we know cosine of A is 1/2. What's sine going to be, okay? Well, sine, we said that for angle A, cosine's up here. Angle A's got to be up here, so sine's got to be positive, okay? All right, so sine's going to be positive. And we know that answer. If cosine's 1/2, that angle is 60 degrees, so the sine is √3/2, okay? So here's my cosine, if you can see that. Cosine A is 1/2, sine's √3/2, and I know sine's positive because of this restriction, okay? Now let's go to angle B. I've got sine is 3/5, and that's our Pythagorean theorem problem again, okay? Right down here I've got sine's got to be in this beta angle, B has to be in these two quadrants based on B being less than pi halves but greater than negative pi halves, okay? Right? We're less than this but greater than this, okay? All right? So, and sine was positive, so that's going to put me in quadrant 1, okay, over here. So that's 3/5 hypotenuse. And to do Pythagorean theorem again, the same thing, okay? 3 squared plus b squared equals 5 squared, okay? B is going to be the square root of 5 squared minus 3 squared, b is 4, okay? All right, so this is going to be 4, all right? So that's cosine is going to be what? 4/5, okay? Opposite over hypotenuse, 3/5 sine, adjacent over hypotenuse, 4/5. So I just figured out all the sines and cosines for angle A and B to plug in this formula here, okay? So I just go down here, okay? Okay? And I'm just plugging in sine of A, √3/2 times cosine B, 4/5, plus cosine A, 1/2, times sine of B, 3/5. And I get, this will be, my denominator is going to be 10, okay? So I've got 4√3 plus 1 times 3, and that's 3. So 4√3 plus 3/10, and that's your answer. So basically they helped us out with giving us restrictions on where our angle could be. I said, we started off with cosine has to be here. When we got our sine had to be positive. So that meant cosine positive, sine positive, that would be here. And the other restrictions here, it helped us out again with quadrant run, knowing that we were given a sine as positive. What were we given? Yeah, we were given sine. Sine's positive here and here, but we had to be in this half, so that meant we had to be right here. And so we were able to narrow down both our angles in the correct quadrants, okay? quadrant. Both of them were quadrant 1. Okay? All right, that's it. That's how we got these answers, okay? Pythagorean theorem and SOHCAHTOA, basically, okay? And just combining formulas. You know, we figured out sine and cosine for A and B. All right, that's it. 10 minutes. See you tomorrow.